Okay. So I'm recording the session. After we're done with the session, I will be uploading a link for you guys so you can go back and reference the video if you need to. All right, guys. So as I was saying, in order to determine if you can multiply A and B together, we look at the number of columns in the first matrix, compare it with the number of rows in the second matrix. If they are exactly the same, then yes, we can find the product of A and B. Now, so that's the first step in multiplying matrices. You have to check and see if you can actually multiply them together. And then the next part of this is to go ahead and determine the size of the resulting matrix. So the size, let me write this down for you guys. The size of the resulting matrix. The size of AB. Now for the size of AB, here's what you're going to look at, guys. The number of rows in the first matrix versus the number of columns in the second matrix. So when you multiply A and B together, if you've already confirmed that they can be multiplied, the resulting matrix, the size of the resulting matrix will be the number of rows in the first one by the number of columns in the second one. So in this case, the size of the resulting matrix will be an M by R matrix. So looking down here at the specific example that I gave you guys, we figured out, yes, we can multiply A and B together because these two numbers are the same. So the size of the resulting matrix on this one is going to be basically a 2 by 1 matrix. So the size of the resulting matrix is going to be a 2 by 1 matrix, meaning you have 2 rows with 1 column. All right, so that's the first thing you have to do. You have to establish whether or not you can multiply the two matrices together. Once you know you can multiply them together, then the next step is to go about multiplying. So the question is this: how do we multiply two matrices together? So I'm going to erase this, guys, and start on a new one. Now, to multiply matrices together, what we do is we multiply the row from the first matrix. I'm going to put first matrix right here. I'm just going to put first, guys, meaning the first matrix, multiply it by the column in the second matrix. So you take the row from the first matrix, you multiply it by the column in the second matrix. Now, I'm gonna go ahead and show you guys an example. 2 by 3. Let's say I have this matrix right here. 2, 3, 1, -1, 0, 2. You guys tell me what the size of this matrix is. What's the size of this one, guys? Anybody? All right, somebody said that was Sarah, 2 by 3, very good. So it's got 1, 2 rows, and then for the columns, it's got 1, 2, 3 columns, okay? So that's a 2 by 3. You guys okay with that? Okay, so now here comes the second one. It's -2, 3, and 1. What's the size of the second one, guys? Okay, 3 by 1. Very good. That's a 3 by 1 matrix. Now, we're first going to establish that we can multiply them together. How do we know we can multiply them together? We compare these two numbers right there. So we compare these two numbers right there. If they are the same, that means that we can multiply them together. And then next, we need to find the size of the resulting matrix. So what would be the size of the resulting matrix? Okay, very good. So the size of the resulting matrix will be a 2 by 1. How do we know what the size of the resulting matrix is going to be? We're going to take the number of rows from the first matrix and multiply it by the number of columns in the second matrix. All right. So now, guys, we know our answer is going to be 2 rows by 1 column. So this, by the way, is referred to as a column matrix because it only has 1 column. Likewise, if it only had 1 row, we would call it a row matrix. So now let's go through the multiplication process. For the multiplication process, we would take the row from the first matrix and then multiply it by the column in the second matrix. So guys, here's how it works. We take the 2, multiply it by -2. Okay, so we find the product of 2 and -2. Then we find the product of 1 and 3 and multiply them together. And then we find the product of 0 and 1. We're multiplying them together. And then we find the sum of all of that. So that's how we come out with the first element. So to find the first element, which is in row 1, column 1, we're going to multiply 2 times -2 plus 1 times 3, and then plus 0 times 1. So you do the work. 2 times -2 is -4. 1 times 3, that's 3. And then 0 times 1 is 0. We add all of this together. So the first element is -1. Right? So the element in row 1, column 1 is -1, guys. Now we're going to do row 2, column 1. So again, now think about this, guys. We're multiplying row 2. This is row 2 right there. And we are going to multiply it by the column of the second matrix. I'm going to change the color. So we're going to multiply it by the entire column again. So this time, we're going to take the 3, multiply it by -2. Then we're going to take the -1, multiply it by 3. Then we're going to take the 2 and multiply it by 1. So this is what it's going to look like, guys. We're going to do 3 times -2 plus -1 times 3 plus 2 times 1. So we multiply 3 times -2, that's -6. -1 times 3 is -3. 2 times 1 is 2. We add it all up, we get -9 plus 2, which turns out to be a -7. So here is the second element in this matrix in row 2, column 1. So pretty much we're done with this. So the product of these 2 matrices is this right here, guys. A 2 by 1 matrix, or also referred to as a column matrix. All right, give me a thumbs up if you're good. All right, I see 1 thumbs up, 2. All right, anybody else? I see 3. Okay, I see a few more. Excellent. All right, so that one was very simple. So what I'm going to do now is move on to a couple more examples that are a little bit more complicated. So as we go through this, hold on, let me let Kate in. Hi, Kate, welcome. All right. So as we go through this, guys, with the second example, especially if this is the first time you're trying this, ask plenty of questions, okay? Don't sit there not asking your questions. Remember, you can type your questions in the chat box, or you can go ahead and raise your hand, and I'll be more than happy to answer your questions for you, okay? So let me go ahead and erase this, and I am going to write out 3 matrices for you guys. All right, so matrix A is this one right here. It's 1, 0, 2, -1, 3, 4. Matrix B will have the elements. Let me see here. 1, ooh. Okay, I gotta put a 1 in here somewhere. Okay, there we are. 1, -1. Okay. 2. My iPad is a little cracked, so part of this sometimes doesn't appear on the screen. So there's the second matrix, guys. And then the third matrix, matrix C, is going to be 2, -1, -2, and 0. All right. So guys, here's your 3 matrices. Okay, first questions first. What's the size of this matrix right here?
2 by 3.
2 by 3, yep. Okay, so this one is a 2 by 3. Next, what's the size of the second matrix, matrix B? Yes, that's a 3 by 2, 3 rows, 2 columns. And of course, everybody should know that because both the number of rows and the number of columns are equivalent to each other. All right, so then here's the first question. Can we find the product of A and B? Can we multiply A and B together?
Yes.
Absolutely. Now, how do we know we can multiply A and B together? The number of columns, columns in the first one is equal to the number of rows in the second one. So now the question is, what is the size of the resulting matrix?
2 by 2.
2 by 2. Very good. So when we multiply A and B together, we're going to end up with a 2 by 2 matrix. So this is where you might want to go ahead and grab your calculators, guys, so we can start doing some of this multiplication. All right, so let me try and fit all of this on here. I'm trying to squeeze a whole lot. If it gets too messy for you guys, just let me know. So to figure out the elements that are going to go in row 1, column 1, we're going to take the row from the first matrix and multiply it by the column in the second matrix, okay? The first column in the second matrix. So for the element that goes in row 1, column 1, we're gonna multiply 1 times 1. I'm writing it down so you guys can see it, but you don't really have to write it down. You can just put it into your calculators. 2 times -1, and then plus 3 times 2. So 1 times 1 will give you 1 minus 2 plus 6. So what's the answer for that one, guys? Well, row 1, column 1. Anybody? Okay, very good. That's a 5. Are you guys okay with that? All right, so I'm going to move on to the next one. For the next one, I am going to do row 1, column 2. So row 1, column 2, I am going to take the row from the first column, okay? From the first matrix, and multiply it by the second column over here in the second matrix. Okay, I'm trying to circle this, guys, but it's not circling, so I'm just gonna go ahead and point it out. So I'm going to take the row from the first matrix and multiply it by the column in the second matrix. Now, what is that going to give me? That's going to give me row 1, okay? And I'm trying to write a 1 here, column 2. So for me to multiply those, I'm gonna do 1 times 2 plus 2 times 0 plus 3 times 4. Obviously, this cancels out. So you get 2 plus 3 times 4, which is 12. So that would be 14. Okay, so now we're gonna move on to the second row, guys. For the second row, we're going to take the second row from the first matrix right here and multiply it by the first row in the second matrix, just like we did with the first one, except we're moving now to the second row. So for this one right here, we're going to do row 2 times column 1. So we're gonna multiply them. Now you guys give me the answer for that one. All right, Joey just said 9, Jasmine, Gabby, very good. Sarah, excellent. Everybody got 9. Excellent. Anybody want me to work it out to show how I got the 9? You can type in yes, or you can give me a thumbs up if you want me to work it out. Okay, so that means that we're good. Okay, good. So then we're gonna move on now to row 2, column 2. Now, for us to multiply row 2, column 2, we're going to take the row from the first matrix and multiply it by the second column in the second matrix. So you guys go ahead and multiply them together. What would the answer be?
16.
16. Very good. Okay, guys, excellent. All right. So give me a thumbs up if you were good with that one. Okay.
Let's ask a question.
Uh-huh.
So, like when you multiply the row in the first matrix, so when there's like multiple columns in the second matrix, you have to multiply that by all the first row, like.
Pretty much, okay? So what you're doing essentially is taking the row from the first matrix and multiplying it by each column in the second matrix. Now, as you multiply them, you have to keep track of where the answers are going to go in the resulting matrix. So if you take the first row, you multiply it by the first column, so that's gonna go in row 1, column 1. But if you take row 1 and you multiply it by the second column, that's gonna go in this position right here in row 1, column 2 in the resulting matrix.
Okay.
All right, guys. So now here's my next question to you. The question is, can we multiply B and C together? Can we find the product of BC? Can we do the product of BC?
Yes.
All right. I'm going to let you guys do that one, but one more. Can we do the product of AC? I might have to do another one too. Can we do the product of AC?
No. No.
Why not?
Because the number of columns and the number of rows in matrix C does not equal to each other.
Right. So A is a 2 by 3, while C is a 2 by 2. So because the number of columns in the first one is not equivalent to the number of rows in the second one, no, we would not be able to multiply these together. All right, excellent. What if I were to say, can you multiply CA together? Could that work out? Could we multiply CA together? Yes, we can multiply them together. So does the commutative property hold true for multiplying matrices? Does it hold true? The commutative property, does it hold true when it comes to multiplying matrices? And you guys remember what the commutative property has to do with? Okay. Now the commutative property, let me see here. Okay. The commutative property basically says this: the order in which you carry out your operation doesn't make a difference. So in this case, if the commutative property were to hold true, and I were to multiply A and C together and multiply C and A together, if I multiply A and C together, I would get the exact same answer as multiplying C and A together. Well, we just figured out, guys, when we try to multiply C and AC together, we can't. But when we try to multiply C and A together, CA, we can. So because we cannot multiply AC, but we can multiply CA, the commutative property here does not hold true for multiplication of two matrices, all right? So I'm gonna give you guys an opportunity to find the product of BC. Find the product of BC for me, guys. By the way, everybody, I don't have a graphing calculator in front of me. We can also multiply matrices on the graphing calculator. I did talk about how you input the matrices into the graphing calculator before we left for extended spring break. So hopefully you guys remember how to do this. So if you want to experiment on your graphing calculator, you're welcome to. Unfortunately, I can't show it on here right now. So if you are having a difficult time with how to do it on your calculator, you're welcome to stay. Oh, actually, I can't stay after with you guys, but I'll schedule some time for you guys to come in and ask some additional questions. On Friday, guys, if we want to have an extended session, we can have an extended session, because on Fridays, I only have a session with you guys. So if you have a lot of questions for me, make sure you save them for Friday. All right. So let's go ahead and tackle this one. If we multiply B and C together, guys, what would be the size of the resulting matrix?
3 by 2.
3 by 2. Very good, Paige. So basically, we're going to have a matrix that has 3 rows and 2 columns. All right, so now we're going to find the value or the elements in row 1. We could also refer to it as an entry. Row 1, column 1. We want to find the entry in row 1, column 1. What's the answer for that one, guys? Row 1, column 1. All right, very good. I think that was Sarah. Very good, Sarah. Anybody not know how to get the 0? Raise, let me see here. Raise your hand or give me a thumbs up if you wanna. No, that would be a thumbs down. We don't have a thumbs down. Let me know if you want me to go over that 0, guys. You good? All right. So next, we're gonna move on to row 1, column 2. Now, when you're multiplying row 1, column 2, you're basically, here, let me point it out. You're multiplying 1 times 2 plus, oh, I'm sorry, I'm putting in the wrong thing. 1 times -2, which is -2, plus 2 times 0, which gives you 0. So what would be the resulting element for row 1, column 2, guys? Oh, very good, -2. That goes right here in row 1, column 2. Okay, so now we're gonna move to the second row. So we're gonna find the element in row 2, column 1, and then row 2, column 2. And then we move on to the third row, row 3, column 1, row 3, column 2, okay? So once again, you multiply the rows in the first column. You guys, can you guys see me? No? Okay, that's fine. So you multiply row by column, row, column. Oh, you guys can actually see me too? Okay, row, column, until you're done. You just keep multiplying. Row, column, until you're done, okay? So let me see here. Who's got the answer for row 2, column 1? What's the answer for row 2, column 1? Row 2, column 1, yes, it's definitely -2. Now, row 2, column 2, what's the answer, guys? Row 2, column 2. Okay, very good, that's 2. Awesome. Wait, so how did you get the 0? Okay, Presley, are you talking about this 0 right there? Yes, you see the little circle moving? Are you talking about that? That's my little pointer, guys. You talking about this? Okay, Presley, go at the top of your screen. You should be able to, it gives you the option, click on the options, and then it gives you an option to annotate. So I want you to go ahead and click on that, and then write on the screen, or show me on the screen what you're talking about. Are you talking about the 0? No? Where does it do that? Okay, go to the top of your screen with your cursor. It should give you the an option to view options. If you click on that, can somebody try it and see if it's working? And it gives you the option to annotate. Oh, look at that. Awesome. I see you. I see. Oh, very good. Very good. Excellent. Okay. So, Presley, here's how you find the 0. Very good. All right. To find the 0, Presley, because this is in row 1, the 0 is in row 1, column 1. So we are going to take row 1. Here, let me try and circle this for you. Row 1. And multiply it by column 1 in the second matrix. So when you multiply, Presley, you would do the 1 times 2 plus 2 from the first matrix multiplied by -1 in the second matrix. So 1 times 2 is 2. 2 times -1 is -2. So when you add them together, you just get 0. Okay. You're good? Yes, yes, yes. Okay, excellent. All right, guys, so let's finalize this one. Row 3, column 1, and row 3, column 2. So for row 3, column 1, guys, what's the answer for that one? Okay, I see a -8. Okay, did everybody, I got a 0 from someone else? Ew, some of you are a little confused. Well, let's check it out. All right, guys. So when we're doing that one, we're going to take 2 multiplied by 2. That's 4. Then we're going to take 4 and multiply it by -1. 4 times -1 is -4. So when you add them together, yes, Joey, that would be 0. So this one is 0. And then the last element, guys, in row 3, column 2, row 3, column 2 would be what? -4. Excellent. Okay, so guys, that's how we multiply matrices. How are you feeling about multiplying matrices? You're good? Awesome, awesome. Okay, so I am going to leave this alone and I'm going to move on to something else. I am going to go ahead and talk about partial fraction decomposition. Partial fraction. Ooh, come on now. That's supposed to say fraction, guys. Decomposition. Okay. Now, wait, I'm confused. Okay, is it too much to ask for you to write the equations? Oops, never mind, you moved on. Okay, all right, Paige, okay, talk to me about what you're confused with.
How did you get 0 for row 3, column 1?
Row 3, column 1, if I recall correctly, we had to multiply 2 times -2, and then 4 times 1 or something like that. So
-1.
Oh, it was -1. So then that means that this one was a positive. So that was a positive. So when you multiply them together, you get a +4 plus.
No, there was a -2. It was -2 times 2 and then 4 times -1.
Oh, Shazam.
No, wait. No, it was a +2. Hold on, my writing messed me up.
Okay.
My bad.
Okay, that's fine. All right, Presley, I know I moved on, but do you have a general idea of what your question was about? All right. Now, Presley, the beautiful thing about using this technology is that this is being recorded. So I am going to upload the video for you guys. By the way, the previous one that we did on Monday, guys, it was horrible. So that's why I didn't upload it, okay? This one right here, we will be uploading it, okay? I still don't know which numbers I'm using to get the new matrix. All right. Are you talking about the size of the matrix, or are you talking about the elements which go inside the matrix? Are you talking about the size or the elements? Oh, okay. Whenever you're finding the elements that go inside the matrix, it's a combination of multiplying the first row in the first matrix by the column in the second matrix. So you're basically doing row from the first matrix by the column in the second matrix. So let me do a quick example for you before I start on partial fraction decomposition. Earlier, I asked you guys, which one was I talking about? Was it CA or AC that we could multiply, guys? I think it was CA. Okay, CA, I asked you guys, could we multiply them together? And you guys should have them. Okay, thank you, Sarah. All right, CA, yes, we can multiply them together. Now, C had the elements 2, I think -1, -2, 0. You guys correct me if I'm wrong because I don't have the matrices in front of me and I'm trying to write them from memory. And A was a 2 by 3 matrix and it had the elements 1, 0, 2, -1, 3, 4. If you guys are looking at your notes, please let me know if this is correct. Okay, all right. So this is a 2 by 2 matrix. This is a 2 by 3 matrix. So these two are the same. So that's verifying that we can multiply them together. So then the size of the resulting matrix is going to be a 2 by 3 matrix. So we're going to set up the 2 by 3 matrix to receive the elements in the 2 by 3 matrix. All right. So Presley, here's how we do the multiplication. I am going to take the row in the first matrix and multiply it by each row in the second matrix. Multiply it by each row in the second matrix. So when I multiply the first row by the first column in the second matrix, I am going to multiply, I'm going to point it out for you, hopefully you're looking. So you take 2, you multiply it by 1, plus you take -2, multiply it by 0. So it will be 2 times 1 plus -2 times 0. And so when we multiply these together, we get 2. Now notice I wrote it down. This is going to reflect the element that is in row 1, column 1. So 2 would go right there, Presley. Are you good on this one? All right, Presley. Now, do you want me to keep going or are you good to just move on your own? Could you do another? Okay, all right. So now, look, I am going to do row 1, column 2. Row 1, column 2, row 1, column 2 would go right there. So when I multiply row 1, column 2, I'm going to take the 2, multiply it by 2. Then I'm going to take the -2, multiply it by -1, and add them together to find the value that goes into row 1, column 2. So for this one, I am going to do, let's see here, 2 times 2 plus -2 times -1. So I end up with 4 plus 2, which gives me 6. There you go. How's that? You good? Awesome. Do you want me to do another one or I can move on? All right. Okay, so we're gonna go ahead and move on, guys. Now, guys, listen, ask me questions. You can either ask me the questions in the chat box. You can raise your hand and throw out your questions. It's up to you how you want to do this. Okay, now who am I missing today? All right, I'm missing a couple of people. I gotta find out who I'm missing today. Okay, guys, so I'm going to go ahead and move on from here into partial fraction decomposition. Now, partial fraction decomposition, I believe, is section, hold up a second. By the way, we're going all the way to 11 6, I think, where we're solving the nonlinear equations, systems of nonlinear equations. So partial fraction decomposition, I believe, is lesson 11.5. All right, so when we talk about partial fraction decomposition, we're looking at decomposing or deconstructing a fraction to figure out what are the parts that makes up the whole. So you guys remember when you heard something like this before? What class were you in? What are the parts that makes up the whole? The sum of the parts equals the whole. Do you guys remember? Anybody? No? Okay. Well, you guys were in geometry. In geometry class, we figured out what are the parts that makes up the whole segment or the whole line. What are the parts that makes up the whole? So guys, let me give you an easy little problem just to get started with so I can show you what I'm talking about. Hold on a second. Okay, yeah, this one looks easy. So here's a fraction, guys. Now, for this particular fraction right here, the denominator is given in factored form. It's x plus 2 times x minus 1. Your job is to figure out what are the smaller fractions that makes up this whole fraction, okay? What are the smaller fractions that makes up this fraction right here? So if we were to take this fraction and decompose it and break it up into its simpler parts, what are those simpler parts? Okay, so guys, there's multiple types of problems we'll encounter when it comes to partial fraction decomposition. I just want you to do some basic ones, all right? So the first one we're going to look at is this one right here. And so this first type is where you have a fraction where you have non-repeated linear factors in the denominator. Non-repeated linear factors in the denominator. When you have non-repeated linear factors in the denominator, it's very simple for you to work this out, guys. So I am going to go through the process with you guys with some steps, and then I will do this problem with you, okay? So when you have non-repeated linear factors in the denominator, by the way, guys, the denominator will not always be in factored form. If it's not always in factored form, then you have to factor the denominator first if it's not already in factored form, okay? So now, to decompose the fraction, this is how we're gonna do it. Since we have 2 factors in the denominator, we're going to first break this up into 2 separate fractions. Now, the catch is this. You don't know what the numerator is going to be, so we're going to use variables in the denominator. So the first step is to factor the denominator. If not factored. Okay, I'm trying to write everything on here, guys. It's difficult, okay? Let me see. If not factored. Okay, hopefully you guys can read this. Factor the denominator if it's not factored. Number 2, break up the fraction into its subparts. So I'm going to talk about this for a minute. If you got 2 factors and denominator, then you write 2 fractions. Now, if you were to have 3 factors in the denominator, then you would go ahead and write 3 fractions for the parts. So on this one, guys, we have 2 factors in the denominator. So when we break it up, we're going to break it up into 2 separate fractions. So the 2 separate fractions would be this. The first one, since we don't know the numerator, we're going to say it's going to be a over the first factor in the denominator, x plus 2. And then for the second one, okay, the second factor, we don't know what the the numerator is, so it's going to reflect b over x minus 1. All right, ask me some questions, guys. Anything? All right, so I'm going to go to the next page. And remember, you can ask me your questions in the chat box or raise your hand or something so we can speak up so I can recognize you. All right. So guys, let's get back to this. It's 3x over, let me see, x plus 2. Somebody remind me what it is. X plus 2, x minus, you know what? I need to look at my problem.
1, x minus
Okay,
1.
X minus 1. Very good. Okay, so this is where we're at. A over x plus 2. And then plus b over x minus 1. Now, step 3 is to go ahead and solve this. All right. Now, how do we solve this rational equation? Well, in order to solve this rational equation, we have to find the LCD and multiply each term by the LCD. Okay, guys. So what would be the LCD? Oh, yes, I saw that. That was Jasmine. Thank you, thank you. I put a -3. That was a -1. Excellent. Okay, guys. So what's the LCD for this one? LCD for this one. Okay, so the LCD, guys, remember, is a product of all the denominators, but when you have a repeated factor, like x plus 2 and x minus 1, you use them once. So the LCD for this one will be x plus 2 times x minus 1. And usually you can just eyeball the problem. Whatever you have in the denominator, that's going to be your LCD. So now, guys, we're going to multiply the entire thing by the LCD of x plus 2 times x minus 1. Okay, so when we take this, the LCD, multiplied by the first fraction, it is going to simplify to 3x. That's the left side. On the right side, when we multiply the first fraction here by the LCD, the x plus 2's are going to cancel out. So this will leave you with a times x minus 1. And then we're going to do the same thing with the second fraction on the right side. So when we take this LCD and multiply it by the second fraction, the x minus 1's will cancel out, leaving you with b times x minus 1. Are you guys okay with this?
Isn't it x plus 2, not x minus 1?
Shazam. Okay, now let's rectify that. Okay, so I'm going to go back in there and put an x plus 2. There we go. Excellent. All right, guys. So now we're going to go ahead and carry on with the problem. We're going to distribute the a. So we get ax minus a plus bx plus 2b. Are you guys okay with that? Okay, so I'm going to keep going.
Zero.
Uh-huh.
Is it ax minus a plus b, or what's that one there in between the a and the b?
Oh, that's a plus.
Okay.
So now, guys, on the right side, I'm going to rearrange the terms. Okay, so when I rearrange the terms, I'm going to get ax plus bx minus a plus 2b. That's 2b. Next, on the right side, notice both of these terms, they have an x in common. So I'm going to factor out the x. So I'm going to end up with a plus b times x when I factor out the x. And then, of course, I still have my minus a plus 2b. All right, we're almost there. And here comes the exciting part. We're going to equate these. What does that mean, to equate them? So let's look, guys. These two are equal to each other. This right here is a plus b times x. Over here, this is 3 times x. So since the x has a coefficient of a plus b, and the x on the right has a coefficient of 3, that means that the coefficient here, let me change the color so you guys can see what I'm talking about. So this means that when I equate them, a plus b will be equivalent to 3. Okay, I'm gonna write it up here, guys, because I don't have enough room. So it's gonna be a plus b is equal to 3. Now, for the second one, this one right here, that is a constant. That represents a constant. There's no constant over here, but what constant can I plug in on the left side and make sure that it doesn't affect this term right here? What constant? What constant can I add to 3x so it doesn't affect the 3x, guys?
0.
Very good. So this means that when I write my second one to equate it to the constant, it's going to be negative a plus 2b equals to 0. Now, guys, that is the exciting part. Now, we're going to have to solve for a and b. What do you notice about this? A plus b equals to 3, and then negative a plus 2b equal to 0. What do we have here? Anybody? Ooh, I was hoping you guys would come up with it. What do we have here? Anybody?
A system equation.
Very good, Paige. Excellent. So we have a system of equation. So now we're going to solve the system of equation in order to come out with the solutions for A and B, guys. Now, this is probably the only one I'm going to be able to do with you guys because we're almost out of time. So I'm going to now go ahead and erase parts of this rather than having to write the entire problem over again. I'm just going to erase some of this so I can go ahead and continue with the problem. Okay, let me write this down so I don't lose it. A plus b equals to 3, and then negative a plus 2b is equal to 0. Now, you guys go ahead and solve it for me so I can erase all of this so I have room to write down the problem. All right, guys. So, what did you get for B? Oh, excellent. Awesome. So, guys, we are going to use elimination. And we are going to eliminate A because the signs are opposites of each other and the coefficients are the same. We add, so we get 3b equals to 3. So then b is equal to 1. Now, if b is equal to 1, then the value of a will be 2. Now, remember, the goal was to find b and to find a, which were the numerators. So basically, this is what we're going to end up with, guys. So when you decompose this fraction right here, when you break it up into its parts, the parts are going to be 2 over x plus 2, and then plus 1 over x minus 1. So what does that mean? It means this, guys. If we were to add these two fractions together right here, okay, these two, if we were to add them together, it would lead us back to 3x over x plus 2 times x minus 1. So, bottom line, these are the two simpler fractions that makes up this fraction right here. All right, ask me a question. I heard a question coming.
Miss Elsera, the numerator, like for the decompose, so would it be like 2x? Because when it equals, as it equals 3x, so would you put the x in somewhere or what?
No, no. Okay, I know what you're talking about, Lee, but that's coming up next. The only way you would have an x in the numerator, Lee, is if this was a quadratic in the numerator to start with, because this is a linear term. Remember, we're only looking at linear factors, so the answer, when you get it, they have to be constant. So in other words, the answer must be less than, the power in the answers must be less than the power in the original problem. So
Okay.
if this was a quadratic, then yes, you would have had an x value somewhere in the numerator of these two fractions over here.
Okay, I see.
All right, guys. So that was the first partial fraction decomposition. Let me see, what time is it? It's about, it's 9:57. So I'm gonna have to end it here today, guys, because I have another session coming up at 10 o'clock. However, on Friday, we'll meet again at 9 o'clock. And on Friday, I can spend way more time with you. And so make sure you get your questions together so that when we come in on Friday, you guys can ask me as many questions as you can. The quiz is on my math lab for chapter 11. There's only one quiz. So make sure you guys are working on the assignments for chapter 11. And I would finish up the homework first before I go ahead and do the quiz. We are going to be having our tests next week, guys. So I'm going to end the session now. I'm going to stop this recording, and then